Hi all, let's now move on to visualizations. Visualizations are an excellent tool for understanding our convolutional neural networks, what kind of convolutional features we have obtained, and how we can improve them to get better models. So first, let's start with saying that convolutional activations we can also find them in the literature as feature maps. So feature maps are just the outputs of convolutions, and a deep network has several hierarchical layers, so several convolutions in a cascade. So we're also going to have several hierarchical feature maps, from less to more abstract, like in this example, where in the initial feature maps we observe more specific, like edge-like types of features, and the further we move to the right, we have more abstract and car-like types of patterns. So what does excite feature maps? If we go layer by layer and start from some random feature maps, we can retrieve the patches in the training set which activate them the most. So for the first layer, we observe that the patches that activate most the feature maps are very similar to the feature maps themselves. So edge-like patterns, either from light to dark regions or from dark to light regions here, or uniform patches. So very low-level information, very specific low-level information. When we move on to the second layer, we go one layer up to abstraction. We have like more abstract circle-in-circle shapes, which correspond quite likely to eyes, right? So to eyes of birds or eyes of animals. Or we can have like corners of shapes like doors, and it's also important to realize that all these layer 2 feature maps are basically linear combination. Well, not just linear, but they're combinations of layer 1 features. So the circle-in-circle feature map will be a combination of 2 circular feature maps from layer 1, and so forth. In layer 3, we've got more abstract and elaborate patterns, for instance, cell-like structures, which correspond to grid type of patches. We also have other types of feature maps that are harder to connect to a word, but they're very recognizable visually, right? So they're very consistent. For instance, some sort of upper body figure, or some sort of star-like shape. And if we go to higher and higher layers, we obtain even more specific and more abstract and object-like types of feature maps. So it seems also that similar activations come from semantically similar pictures. So at some point, you have some sort of dog face neuron, or some bird feet neuron. We have specialization. So this what visualizations teach us, that as we move on to deeper and deeper networks, we obtain we learn convolutional filters that specialize more and more to specific objects. Whereas in the first layers, we're going to have very specific edge type patterns. The deeper we go, the more specialization we have, hopefully. Over training, we can also visualize the features. We observe that in the beginning, the layers, layer 1, 2, 3, 4, 5, they are a bit more blurry, not as clear as we go deeper. So whereas in layer 1 we've got a quite concrete idea of what the filter is going to be about, in subsequent layers it's still a bit unclear. However, the more we move on to during training, the more specific the features become. So this is like time 1 and time 64. A good question is, however, do the filters therefore specialize on objects? It seems to be like that when we visualize features. One can actually also produce heat maps class heat maps to observe, like classifier probability of correct class. And indeed, we observe that, for the case of a Pomeranian dog, the feature map is indeed centered around the dog's face. When in the car wheel case, here we observe again very similar patterns. Let me see. So for the car wheel, again we observe that the activations are in reasonable places, like on the wheel and on the door. And the same for another case of Afghan hound. It doesn't matter that we're occluding here. The results are consistent. So another question is, what is a confident dog? What does the convolutional neural network learn when it classifies a picture as dog? In their paper, Simoian et al. And others try to find, what is the most dumbbell type of picture or the most cup-like of picture. And of course, this picture will not be a real picture. It's more like which picture would maximize the score of a dumbbell class or a cup class or Dalmatian class. And to do that, they expressed an objective here and a minimization objective, and they could also adapt it to discover pixel-wise class saliency with very interesting results. So in this example here, they're visualizing what kind of image does the convolutional neural network expect when recognizing dumbbells, and we indeed observe some dumbbell-like shapes. The same for cups here, or for Dalmatians, we see these checker patterns. So these are basically the patterns that the neural network expects for perfect recognition. And regarding the class saliency, we do again observe evidence that the neural network has learned to recognize object-specific locations as relevant to the class.